Good day, everyone. Welcome to our second class on Fusion 360. In our previous class, we made mention of solid and surface modeling, and I showed you some examples. So, in today's class, we are going to focus more on joints and assemblies using the inspection tools, decal and canvas, and how to use them to create or modify your designs. I'll also show you some examples on design modifications. Learning objectives for today. After completing today's lesson, you will be able to create 2D and 3D models, modify your designs using the modification tools, create joint and assemblies, and design relationship. You'll be able to use the inspection tools. Also able to use the canvas to create profiles and also apply decals on model. For our first example, we are going to recreate these chess pieces. This is a chess pawn, one of the popular chess pieces. It's called a chess pawn. We are going to recreate this in our Fusion 360 environment, design environment. Okay, and we are going to do that using a chess canvas. Okay, so the first thing we are going to do is to import our canvas. So a canvas is an external file, external image file that you can import into your Fusion design work environment and use it to generate a sketch. Use it to generate a sketch or profile or models. So the first thing we are going to do is to go to our insert tab under the toolbar. Go to the insert tab, which is located at the top left corner. Click on the insert drop down menu, then scroll down to canvas. So you find your canvas there, select the canvas, activate the canvas tool. So the insert dialog box will be open. So you have the option to insert it from your cloud storage, which is your admin project. So you remember I told you in our previous classes that whatever you save, any design you make and save in Fusion 360 will be saved in the cloud. So you can import your canvas from the cloud, your cloud storage, or you can insert it from your computer. So at the bottom left corner of this dialog box, you see the option to insert from your computer. So we are going to click on that. It will open our system files. So we will search for the pawn canvas that we want to use. Okay, I think we are going to use this one. I'm going to insert this into our design. And how you do that is by left clicking to select the image you want and click on open. It will now be inserted. Our canvas dialog box will be open. So our canvas dialog box is now activated, which is this. Okay, this is the canvas dialog box. So it prompts us to select the face. So our image has been inserted, but it has not displayed in our canvas. So what do we do in our design workspace environment? So what do we do? It wants us to select the face or plane where we want that canvas to be inserted in. So I'm going to select either the ZX plane or the ZY plane. So any of them is fine. So I'm going to select the ZY plane or ZX plane. I'll select one of them under the fixed selection. Let's click on that to select it. Then you have more options in that canvas dialog box. You're going to have more options now. Okay, this parameters gives you the ability to adjust this canvas. These parameters give you the ability to adjust this canvas, so you can place it anywhere you want. You can move it around. Okay, if you want it to be at the origin, want it to start from the origin, you can move it towards there. You can scale it up. Okay, you can see you can scale it up. Okay, I think I'm okay with this. You can also use the parameters here. You can flip it in the horizontal direction. You can see this can flip it in the vertical direction. It has been flipped upside down. So you can also flip horizontal. That's okay. But we want it to be, we don't want it to be upside down, so we want the head to be facing up. So I'm going to flip it again. So I'm okay with this. So you can adjust the parameters to meet whatever you want. So we are going to work with this. I'll click on OK. Right. So the next thing we are going to do is to create a sketch on this canvas. That's the next step. That's the next thing we are going to do. So in order to create a sketch, we will go to our create drop down menu and select the create sketch command. By left clicking, we activate it and select this plane where we inserted that canvas. Remember, we selected this ZX plane. So that's the plane we are going to select in this case now. So okay, now our sketch environment has been activated. So the next thing we are going to do is to trace out this pawn sketch profile, to trace out this chess piece out from this canvas. So, and in order to do that, you can either use any of the line tool, either your line straight line tool or your spline tool to trace out this irregular shape. If you want to trace out irregular shape in Fusion 360, you have the option to use your spline command, which is this. You have the fit point spline or the control point spline, any of them. You can use it to trace out irregular shapes, your line command. But if it is a straight line, you can use the line command. Okay. So, but in this case now, in this example, if you look at the pawn chess piece, you will observe that it is symmetric, meaning that if we should divide this into two, if I should slice this, sorry about that, let me redo that. Okay, if we should slice this into two, okay, you can see that the right hand side is identical to the left hand side. So if you have any geometry that is symmetric in this nature, you don't need to start tracing out everything because you will want both sides to be equal and identical. So the best way you can generate such design is to trace out one edge and create a revolve. You use a revolve tool to create a circular revolve command. So that will generate the entire model for you without having to trace out everything. Okay, and the our model is circular in nature, circular in nature, so we can trace out one part and then revolve it. So the first thing we are going to do is to activate our spline tool. So our spline tool is located at the top of our sketch tab. So you can also you can activate it from here, or you click on the create drop down menu and select and scroll down to spline. You have two options: the fit point spline and the controls point spline. In this case, we want the fit point spline. Okay, so we are going to start from one end. So you can always zoom in to make sure your sketch is accurate. So I'll start from this end. Assume here is the center point. Then I'll start tracing it. It might not be as accurate as you want, but it doesn't matter. You can always edit the point by moving them. Okay, we're going to create a rough sketch. So I will quickly run through that to save us time. Okay, you can see this is a simple operation. Just trace it. If you are not okay with the place you positioned a point, you can always use Ctrl Z to go back to your previous point and continue. Okay. Don't worry about the position. You can always edit that. Okay, almost done. See, Canvas gives us the capability to trace out or to generate design from existing images without having to worry about the dimensions or geometry of that particular design. Okay. So I'm almost at the center, so I'm going to click this check mark button. So you can always go back and I will exit my spline tool by using the escape button or you clicking on the select tab. So I will try and edit this to match the shape of my model. You can always move the point. Okay, I'm okay with this here. Okay, you can also add constraints to your spline, your spline tool or your spline sketch. Very regular, so you can ask constraint. If I want this line to be straight, I can use the horizontal vertical constraint to strengthen them. If I want a point to be coincident, I could use the coincident constraint to do that also. Okay, but in this case, I just want a simple sketch, so I will not be using any constraint on them, right? Okay, so we're almost done with this. Okay, with what we have here. Okay, so we are done with the sketch. So we've gotten we've been able to trace out the half of our geometry. So the next thing we are going to do is to draw a straight line from this point to the top of this one to create a close profile and to get the half, to divide this canvas into two sections, two equal sections. So I'm going to activate our line tool by going to the create drop down menu and select the line command. Okay, I will come to the top of my profile and select this first point. Then I will scroll down to the bottom in a straight line at 90 degrees. I will select the second part. Now we now have a closed profile. Okay, so I can select this closed profile and revolve it to get our bone chest piece. So I'm going to click on finish sketch to, to take us back to our design workspace. Okay, so you can always turn off your canvas when you are done. You've gotten the sketch profile that you need. You can always turn off your canvas in the browser tab. So I'm going to go over and turn off this canvas. So I will be left with just my sketch profile. So the next thing we are going to do is to activate the revolve command, and you can do that by going to the create drop down menu and select the revolve tool, which is this. You can activate it by clicking on it, or it's at the top or the top of your tool tab. So you can also select it here. So we now have our revolve dialog box. So by default Fusion has selected a profile for us, but in case it doesn't, you can always select the profile, which is the first option there. Select the profile you want to revolve, then select the axis you want to revolve around. So the axis is the center line you want that profile your profile to revolve around. So I'm going to select this axis. I want it to revolve around this axis. So I'll select the axis and I'll say 360. that is full. Say okay. Okay. So now we have our chess piece. You can see this is a raw sketch. We are going to edit this bottom so that we have a flat surface. Okay. So this is a rough sketch of our Fusion chess piece. This is the pawn chess piece. Okay. So let's go back and edit the flat surface so that it will look more realistic. All right. So you can go, we'll go to our browser tab. We'll go to our browser tab. We'll go to our browser tab and we'll go back to our sketch and activate, re-edit our sketch profile by clicking, right clicking on it and selecting the edit sketch. Okay, so we need to edit this bottom so that we have a flat surface. All right. Okay, and we can do that by selecting, activating our line tool, which is at the top, which is present in our toolbar. So I will click to activate our line tool, and I will draw a line from this point straight and perpendicular to this one. Okay, if it's not straight, you can use the vertical horizontal constraint to straighten it. Okay, so I can now we can trim out this other one, this XX one, without having, we will no longer need it. So I'm going to use my trim tool at the modify tab. Select the trim tool and trim out this. Okay, I'll cut it out. I'll cut this also. So we are going to work with this. So I'll say, once I click on finish sketch, Fusion will automatically update the design. So I'll click on finish sketch. As you can see, shows, check the bottom, we now have a flat surface at the bottom. So our design looks more realistic. So this is one of the ways you can use canvas. You can use canvas to generate your design. So if you are trying to create complex geometries that you don't really know how to go about it, one of the ways you can fix that is to go online, download the image of that particular design you want to do, insert it into Fusion environment as a canvas, then you now use your design tools to trace out the geometry. So that's one of the ways you can do that. So our next example, we are going to be talking about creating using decals, which is one of the things we'll talk today, decal and canvas. Okay. Now learning objective should be able to apply decal on model. So the next example is to create a solar panel. So using our modeling tools and our decal to create a solar panel. So I'm going to activate a new tab, a new design tab. So we are first of all, we are going to create the board, the solar board. And in order to do that, I will select our, we are going to open our sketch environment. So we're going to create a new sketch. We'll go to our create drop down menu, click on create sketch, and select the XY plane. Okay, our sketch environment will be activated. All right, so in this case, I'm trying to create a solar panel that looks like a box, something similar to this, or a rectangle. So I will activate my rectangle command. I'll go to my create drop down menu and hover over whole rectangle, which is the second option there. Instead, you have several options. You can use the 2-point rectangle, 3-point rectangle, or in this case, I want to use the center rectangle. So I will click and activate the center rectangle. So whenever you are using the center rectangle, your calculation or your drawing will always start from the center point. That's just the difference. They are all the same. You all used to create rectangle. So I will click on the origin, and you can always click it anywhere. It mustn't be the origin. So I will click on the origin and adjust I'll increase parameter of 100 by 80 millimeter, which is what we have now. So I'm okay with this. I'll click again. Let's click again to create our rectangle. So this is the board we want to use. So the next thing I'm going to do is to offset the edges of my rectangle. So under our modify drop down menu, I will scroll down to offset. You can activate it by clicking on it or by using the keyboard shortcut O. Select the offset. our offset dialog box will be activated. Okay, be mindful of this. Whenever you select most of these tools, if not all, whenever you activate them, their dialog box is always open for you to adjust your parameters, for you to adjust the way you are using those tools to create a design. So in this case, you can see that we have chain selection active. So if I should select a line now, it will automatically select all the line connected to that particular line. That is the function of this chain selection. But if we should deselect chain selection and deactivate this and we try to select, you can only select individually because now the chain selection is now deactivated. Okay, we will now have to select it individually. Okay, but if chain selection is active, which is always active by default, when you select a line, it's going to select automatically. Assume you want to fillet every line connected to that particular one. So all of the lines will be selected, which is what we need in this case. So you can always drag to adjust how you want your fillet to be. Okay, fillet is by the meaning of fillet is you are trying to the meaning of offset rather. Sorry, that's I'm using the wrong sentence. It's actually offset, not fillet. The use of this offset is to create another line that is identical to a particular line. So you are trying to like duplicate but in a different dimension. Okay, in a different dimension. So in this case, we are going to work with 3 millimeter. So I'm going to impute 3 millimeter and say okay. So I'm okay with this. So I'll say okay. So you always use the flip button to flip it any way you want. If you want it to fillet outside, you can always click on flip to fillet outside. If you want it to fillet inwards, sorry, I'm still using the fillet. Or I don't know why I'm using fillet. If you want it to offset, rather not fillet. I'm sorry about that. It's offset, not fillet. If you want it to offset inwards, you can use the flip to offset inward, which is what you want. I'll click on OK. All right. So we are going to close our sketch and convert this into solid bodies. So I'll click on finish sketch, we'll return to the design environment. The first extrude we are going to do is the inner one. So we're going to activate our extrude command. Activate our extrude command. We have our extrude dialog box. I'll select the internal profile. We are going to add an extrude of, let's say, no, 5 millimeter is too much, so we are going to go with 2 millimeter. Okay, so or 1 millimeter. Okay, so this is what we want. Say okay. All right, so our sketch profile this has disappeared. So don't really, well, anytime your sketch profile disappears after completing an operation and you still need it to do the next operation, you will just go to your browser tab, which is at the left hand side. Under the sketch section, you click on the drop down and you reactivate your sketch profile. So we are going to carry out another extrude operation. I will activate my extrude tool and select the profile, outside profile we want, outside profile. Then we will now extrude. The first one is 1 millimeter. So this one will be 1.2. 1.2. Okay. So I will use join. Say okay. Okay. So this is what we want. So I can now turn off my sketch profile. So because we no longer need it. Okay. So we are almost close. Okay. So I will add another extrude so that it will look more realistic. So we are going to re-edit this extrude in, rather than creating another extrude command, let's edit this one and make it look more realistic. You can see when you go to our edit feature, our extrude dialog box, scroll to direction, you can see it's set at one side, meaning that the extrude is the profile is being extrude in one direction. So we can change that to two direction. You click on it and change it to two sides rather than one side. Okay, in the second side we are going to drag it down a little bit. Okay, in this case we will use 3 millimeter, 3 millimeter, and click OK. So you can see how we just edited that previous extrude command rather than creating new one. So we have our solar board. So we want to, in order to do this is our solar panel. Rather, this is our solar panel. Sorry, not solar board. This is our solar panel. Okay, so it's but we've not getting the final product. So we are trying to generate something that looks very realistic, such as this. So what we are going to do, instead of individually drawing this section in your Fusion, is in your Fusion sketch environment, trying to replicate that solar design on this surface, drawing and extruding, which will take you a lot of time and computational resources. So another way you can fix this is to import a decal. A decal is like a label that you can attach to it. So you can import a solar texture or label and attach to it and make it look very real. So that's what we are going to do. So we are going to go to our insert drop down menu, which is at the left hand side. And you click on the insert drop down menu, click on decal, left click on decal. Okay, it will open our Fusion storage. So you just like I told you, by default, any object you create will be saved in the cloud. So you can always add your decal from the cloud, or from you can insert it from your computer. So we are going to insert it from our computer. So you scroll down to search for a solar texture. Okay, so this is the solar texture. We are going to insert this now. Click on open. Okay, our decal dialog box has been opened. So it's prompting us to select the face we want to add that label or that decal on top, or that solar texture on. So I'm going to select this face. I'll click on it. We'll now have more options. So you can now scale to the size you want. All right. So you can always drag. Okay. Okay, you can always drag it and click on this change faces. Okay, click on change faces to deselect that to deselect the decal, because the more as you are trying to scale to upscale the decal to a larger size, it begins to wrap around the edge of your model, which is we don't want that. We only want it to be within that surface that we selected. We are going to unselect change faces, and the moment we unselect it, it will be okay. It will end at that surface, that face we selected. So click OK. Okay, so we now have this texture or this decal added to the surface of our model. So you can see it's now beginning to look more realistic. So the last thing we are going to do is to add our appearance. We are going to activate the appearance. In this case, we'll use a white paint and attach it to drag and drop on our model, on our solid body. Okay, and say close. So we now have a solar panel. See, now have a realistic view of a solar panel. So if you are, let's say you are an engineering student and you are designing a system, let's say a solar powered generator, or a solar powered plant nursery, okay, and you are trying to brainstorm, see how you can come up with the design of a solar panel. So this is one of the ways you can do that easily. You can see how fast and easy it is. Okay, so that's all about decal. So you can always go practice, do some examples to master how to use that particular tool, which is the decal and canvas. They are very powerful tool that can make your design easy and seamless. Okay. And for our next example, or the last example we are going to be doing in this course, in today's lesson, we are going to touch on joints and assemblies. Okay, I want to touch on this joint that we've talked about, using canvas to create profiles, talked about applying decal on models. So before we go over to joints and assemblies, you want to I want to introduce you to the inspection tool. Okay, one of the inspection tool rather. So these tools and design commands that we are using to create this thing are actually more detailed, and there is more depth in them. They are more detailed than this. Okay, this is like the surface level of this. So in our advanced classes, we'll be talking going into detail on this particular tool. So just like the inspect tool that we're about to deal on, okay, I'm about to carry out an inspection on this. So one of the inspect tool is section analysis. So there are several level of there are so many inspection tools here. So under this inspect dialog box, you can find several inspect tools close to the insert dialog box. You can find several, but the one we'll be talking about in this our class is the section analysis, which is the most common used inspect tool. Actually, the two most common is this section analysis and measure, where you can use to measure any dimension you want. Okay, so we are going to talk about measure and section analysis. So the first one is measure. So I will activate it. Have your measure dialog box. All you have to do is select the 2 points you want to measure, or the line, any line you want to measure. In this case, I want to measure this line. So this line is a circle. This line is a circle, so it's going to tell us the diameter of that circle. So if you are trying to know the diameter, the measurement of any of your geometry, you can use the measure tool. So in this case, the diameter of this circle now is 8.05015 millimeter. That is the diameter of this circle. So this is one of the ways you can use your measure tool to check the dimensions of your design. So now let us repeat that in our second drawing. Okay, let us activate measure, which is the first one here. Use I to you can use the keyboard shortcut key I to activate it. Okay, you remember in the previous measure example we did, which is in that chessboard, we selected just a line at the bottom. So in this case, it's not just line. You can select points, you can select surfaces. So let's measure the length between these two, the length of this solar panel. So I'm going to select this surface, click on this surface to select it as point 1. Then I will scroll to the other surface and select this other surface. I want to know the length of this solar panel. I'll click on point 2. You can see it's 100 millimeter. That's the dimension from that surface to this surface is 100 millimeter. And it's written here distance 100 millimeter. You can see it here. Okay, the area is also given, the loop length, other parameters is also given, but in this case, our major focus is in the distance and angle. Angle is 0 degrees and distance is 100 millimeter. So you can also select vertices, you can also select lines, edges too. So if I want to deselect this now, I'll just click on the canvas, it will be deselected. Okay, but our measure tool is not closed yet. So I want to select edges. I want to measure the distance between this edge and the corresponding edge in the opposite direction. I'll select the second point and you have 128.062 millimeter, which is what we have here, also 0 degrees too. So this is one of the ways you can do that. So let's see if we can generate an angle. So we're going to measure from here to here. So this angle this is supposed to give us a 90-degree angle. Okay, you can see we now have 90-degree angle. So it measures the angle between both of them and we have 90-degree. Okay, so this is how you use the measure command, which is an inspection tool, very important inspection tool. Okay, so the next inspection tool we are going to work with is the section analysis, which is this. Okay, and to activate it, go to your inspect dialog box, scroll down to section analysis right before the center of mass. Select the section analysis by left clicking on it, and you can select either the plane or any surface. Okay, in this case, let's select the surface rather. I'll select the surface. Okay, I can now scroll to any section I want to view. Okay, so you can see you can view how the internal section is. So if you have a complex geometries that have some hidden features inside, you can use this section analysis to view how that internal looks like. Okay, so that's one of the ways. So we are going to repeat this section analysis in our chess piece. Okay, so I will activate the section analysis again. But in this case, now rather than choosing the side, I'm going to use a plane. So you can also use, just like creating sketch, you can select the plane or a surface. So I'm going to select this plane and it will divide it into two. So this is the section of the chess piece. So you can always adjust to view it. So if there is an internal geometry inside or a hollow space, if there was a hollow space in this model, you are going to see the the hollow space using this section analysis. So let's try out that example. So I'm going to click on cancel. Okay, so let's use shell command under your modify. Modify is to, if you want to use this under your modify drop down menu, we are going to select the shell command, which is the fourth one there. Click on it to activate it. So shell command adds hole or a hollow surface into a solid body. So I'm going to select the surface where I want to add the shell. Okay, and the direction is inside, means that I want to add the shell inside. So I'm going to click on this surface. Okay, and say 3 millimeter. Okay, there is a little bit of lag and we are generating error. Okay, let's repeat this and say 1 millimeter. Okay, we're generating error. This shape is a little bit problematic. Okay, hold on. The this distance diameter is 8 millimeter, and the here should be 4.5. Okay, let's try using another example rather. Instead of wasting time on this one, let's try using another example. We are going to create a box. Okay, I'm going to create a box too. I will activate my rectangle to 2 point rectangle. Last time we used the 3 points rectangle, but this time I want to use a 2 point rectangle. So I'll select, I'll say OK, finish sketch. Then I'll extrude this rectangle to get a box. Then I'll say OK. So we have our box command now. So I will reactivate that shell tool, select to activate it, then I'll select the surface. So to prompt you to add the thickness, internal thickness, I'll say 2 millimeter. Okay, you can see it has added a shell. It has created a hollow nature inside our box. So okay, so this is how you use the shell command. So say okay. Then if you can, we can now activate our section analysis. Okay, and in this case, I'll select the or surface. I can select the surface too and drag it inward. From the, if you are looking at this thing now, let's assume the top is covered and you are looking at this from this side. You don't know that there is a hollow body inside, or there's a hollow space inside. Using this section analysis and dragging it, but you can see, oh, you finally realize that there is a hollow space inside. So it will now inform you on how to carry out your design moving forward. Okay, so that's how you use the section analysis. So these are the two inspection tools we are going to talk about for this class. So in our advanced classes, we will go more deep into how to use all these inspection tools to carry out analysis in our design process. Okay? So I'm going to close that. So we're going to move over to the next example, or the last example for the class, which is create joint and assemblies. So for this class, I've created some designs, or rather, let me turn off this. Okay, I've created some designs that I will be using to explain how to apply those joint relationships. So joint relationships are used, or joints or assemblies are used to apply fixed or movable relationship between one or more geometries. So you can use it to apply. Let's say you have a shaft rotating connected to a flywheel that is rotating. Okay, you can use the joint and assembly to apply that relationship. Or if you are designing an engine block, okay, and you want to design the crankshaft with the piston, you want to animate, you want it to have that up and down movement of piston in the engine block in an automotive engine. You can use your joint and assemblies to animate it to create that relationship, that upward and that translational upward downward relationship of the cam and piston followers. Okay, so yeah, for the first example, the first we are I don't we are not for this class I'm not going to talk about all joints and assembly. I'm not going to talk about all the relationship. There are several tools you can use to create your joint and assembly and relationship between geometries, but we only talk about few of them. So for the first one is joint. We are going to activate our joint tool under our assembly drop down menu. Under our assembly drop down menu, okay. Under this assembly drop down menu, we are going to click on the drop down menu, select the joint command, or you can use letter J, the keyboard shortcut J to activate it. Select the joint command. We want to add a rigid we want to add a rigid first joint is to add a rigid. You can see this design is moving. Okay. Okay. So the first thing we are going to use is the revolute command. And see, you can see this our tool is can move freely in space, but we don't want it to be. I don't want it to have this movement. I want it to be fixed to this point, and it should have a rotary motion along this axis. So I'm going to revert it to the previous position. So as you can see from our design, I've changed the position of this, but you can always fix it by going back, by undoing, or you go to your under the at the top right corner, you will see the revert or capture position option there. So the first one is to capture position, meaning that you want it to remain in this position, this new position that you've placed it, or revert it to the previous position that it was. So I'm going to click on revert position to send it back to this. Okay, so I want to create a revolve relationship along this so that it will be able to rotate. So the next thing I'm going to do is to activate the joint tool. Okay, I'm going to scroll down to the assembly drop down menu and select the joint. Our joint dialog box will be activated. Okay, and mind you, you cannot add relationships to bodies in the same component. So in order to add relationship between bodies, they have to be different components. Okay, you make sure you cannot add relationship to bodies rather but to components. So if you are trying to add relationship between two geometry, make sure you convert those bodies into components before you add them, or before you start designing those geometries, you create a component in your browser tab and start designing those bodies under them. That's a good design practice. It's one of the ways you can also carry out your design. You can also do that. So I'm trying to add a revolute or revolve relationship between these two bodies so that this outer one will be able to revolve around this. So the first thing is you can see component one is to snap on the first component, to select the first component. So I'm going to select this component. Okay. Then it will prompt me to select the second component. I'll select the second component. Okay. So by default, it is set to rigid. We've placed the position, then we'll switch over to motion. You can see you have two dialog boxes here. The first one is the position, where you select the object you want to add a relationship. While the next one is the motion, you select the type of motion. By default, it is set to rigid. If I should fix it at rigid, rigid means that, just like the word implies, that it should be rigid to that position. That you cannot move it again. If you notice, we cannot move this again around. So it's rigid now to this position. So, but this is not what we want. Okay, so I'm going to go back and edit that. Okay, I will edit that on my just like I told you, you don't need to delete or undo. You can always go back and edit that relationship and change it to what you want. So I'm okay with the selection. I just want to change the motion type. So I'll switch over to motion, and under the type is set at rigid by default. I'm going to change it to revolute. I'll click on revolute. You can see it's now rotating. So I'll say OK. Click OK. So if I should try to move this now, you can see now it's now rotating along that axis. Okay, you can see now our geometry is rotating along the axis. So this is how you add a rotating joint relationship or a Revolut joint relationship as it is being called in Fusion 360. So the next relationship or joint we are going to be talking about is the slider. Just like the name implies, Fusion is very simple with their English. So they use commands or they name their tools with the languages that explain exactly what you are trying to do. So in this case now, Revolut, you are trying to create a revolve or revolution or a rotating relationship between these two bodies. Why in this case slider, like the name implies, you are trying to create a sliding relationship. Meaning that if I should add a relationship, a joint between this body and this one, then it will be able to slide among each other. Okay, so that's what we are going to do. I will go to my assembly drop down menu and select the joint. Okay, I will select the first model, the first geometry I want to add the slider to, and select the second one, which is this one. I'll select the second one, and be careful whenever you are selecting this, because if you might still be in the first component and you double select, meaning that you selected two components. You're only supposed to select one. Okay, so I will select the second one. I've selected both components now. I'll change the motion. It's set at rigid by default, so I'll change the motion to slider. So it will give me the option to select the side I want my slider to be. So I'm going to currently set at Z axis. So we are going to check if X axis is okay. This is not what we want. Yeah, I will select Y. This is not what we want. Okay, so I think we are going to, let's go back to our position and see what we did wrong there. So going to flip. Let me change it to Z. No. Let's reselect this. Okay, so for the first model, let me select this for the first component. Okay, for the second component, I would select this. Okay, this is better. So for the motion, I'm going to change it to Z. X. No. Y. Hold on, just give me a minute. Okay. Okay, let me select that. I think the problem is coming from the selection. I will select this. Let me select this line and I'll select this surface. We are still not getting it, so we are going to keep on trying this until we get it right. Okay, so I will select this. I will select this. I will start with selecting. change the motion to say x axis, no, y axis. Okay, this is what we want, but I'm going to adjust the I'm going to adjust the distance so that we have a perfect slider. Okay, all right, so this is exactly what we want. Okay, if I should click on animate now and see what we have. Okay, exactly, this is good. It's beautiful. So I will click OK. So we now have our slider motion. Okay, so you can see we can now slide easily among our body. So whenever you are doing any, you are creating any assembly, it is very tricky, especially when you start creating complex relationship, complex joint relationships. So you have to be careful on the particular edge you select. So because it could affect how the entire relationship will turn out. So we are going to try out one more joint relationship before we end close the class. Okay, so I'm going to reactivate our joint command. In this case, I'm going to try this ball and socket, this ball joint. So I'll select this ball, okay, and select the body. I will change the motion to ball. Okay, I will select the other one because I want it to be positioned at the center. Okay, so we now have this and say okay. So if we should try to move our ball, okay, it will have a ball relationship, just like if you are trying to create so if you are trying to create any object or any geometry that have a ball and socket joint, you can use this. Okay, just like your rulers, your ball rulers that you use in machines. So this you can use this joint relationship to apply in such geometry. So any design that you are making that needs any kind of relationship like this, or if you are designing, let's say, a tripod stand, like the tripod stand that you attach your camera to it and you want it to be able to rotate at any angle you want. So you can place this ball relationship or joint at the top of that tripod stand where you are going to position your camera. So that's a very good example of where you can use this joint relationship, this ball joint relationship. So that will with that being said, we are going to conclude today's session. So in our next class, we'll be talking more of this, and in our advanced classes, we'll go deep into these joints and relationship. There are so many of them. Okay, so if you notice in our design, whenever I'm trying to do this slider, you can see it goes beyond the model that we want. So we have the option to fix this slider motion so that it doesn't slide beyond this particular edges. So you can also do that in Fusion 360, okay, to make it look more realistic. So these are some of the things we'll talk mostly in our advanced classes. All right. So with that being said, that will be the conclusion of today's class. So in our next class, we'll be dealing more on this, and then I will touch every other aspect of the CAD computer design that we haven't really taught. So thank you for your time, and we'll see you in our next class.